morning. In today's session, we are supposed to study about the three-phase induction motor. So these are the outlines which we are supposed to study. As we have seen, there are different types of induction motor. Actually, there are different types of electrical motor. It means what? If we are saying there is a motor which will convert electrical energy into mechanical. At that time, we are saying that motor as an electrical motor. So that can be AC or a DC. DC motor already we have seen in the third unit. And now here in our fourth unit, we are supposed to study about the three-phase induction motor. So it is the type of AC motor. So here we can see there are different types of AC motor like single phase and a three phase. If we are giving the three phase supply to the induction motor, at that time we are saying that as a three phase induction motor. And if we are giving the single phase, at that time we can say that induction motor as a single phase induction motor. Then we are supposed to study about the basic principle, how it is working, how we are supposed to study about the construction of induction motor. There are different types of three-phase induction motor like squirrel cage and the slip ring. And we are supposed to see about its applications. Already we have done this unit, but there are numericals you are supposed to solve on that unit. So firstly, we will revise this and then we will solve some numericals. Only 2 students have joined it. Okay. So here we are saying electrical machine as a electromechanical energy conversion, or you can say a electromechanical energy converter, because it uses the electrical energy and it is converting that electrical energy into a mechanical energy. And if it is doing vice versa, at that time we can say that as a electrical generator. So these are the two types of electrical machines, like we have seen the two types of DC machine, DC motor or a DC generator. But in our syllabus for the AC only we are supposed to study about the motor. There is no concept of electrical generator. So here only we are supposed to see how it is converting electrical energy into a mechanical energy. Vice versa, no needed. So here, most of the industrial loads are inductive, especially three-phase induction motor are widely used in the applications for continuous operations, because here we are saying this as AC. AC means what? Their operations will be continuous. So here we are saying we can use induction motor in the industrial applications because it is having lots of advantages, like it has low cost, it requires less maintenance, we can say it is reliable, it is very simple in the construction, its power factor is good. Also we can say it is a self-starting because there is no need of another self-starting device. So we can say these are some advantages for the induction motor. But if you see whole its construction, its working, at that time you will get there are some disadvantages of the induction. Like we can say, if we are increasing the load, its speed will decrease. So it will be its disadvantage. Also, its starting torque is less. If we are changing the speed of three-phase induction motor, at that time its efficiency also changes. So these are some disadvantages for the three-phase induction motor. So here we want to see about the three-phase induction motor. So here we are saying about the electrical machine. So there are two types of electrical machine. It can be AC or a DC. DC already we have studied. Now we are supposed to see here AC. So AC, if you see, it is divided in different types, like one single phase induction motor, PS for the phase, and one phase. Three phase induction motor, synchronous motor, single phase transformer, three phase transformer, alternator, or we can say as a AC generator. These are the different types of the AC machine. DC machine, already we have seen there are two types, DC motor or a DC generator. DC motor, DC generator, both already we have seen in the third unit. So here DC motor is divided in subtypes like DC shunt or the DC series motor, or it can be a DC compound wound motor. But in our syllabus, we have seen DC shunt and the DC series. Shunt, when we are saying, if we are not giving separate power supply to the armature winding and field winding. If we are giving power supply to the armature and it is providing to the field winding, at that time we are saying that as a DC shunt. Because here if you see, armature winding and field winding will be in parallel with each other. Series, armature winding and field winding both are in series. Then DC generator, the same types. The DC shunt, DC series and DC compound generator. So here we are supposed to see about the three-phase induction motor. So we can say three-phase induction motor which will uses the electrical energy and it will convert that energy into a mechanical energy. And as here there is no need of any starting device and all of its constructions simple. We are using three-phase induction motor widely in the commercial as well as industrial application. So here we will see its principle of operations. So the construction, if we are talking about the construction, what we have seen, it will consist of two parts. These are nothing but stator and the rotor. So here we are supposed to see how it is work, its principle of operations. So rotating magnetic field is set up in the stator when we are giving the three-phase supply. So already we have seen that concept. When we are giving the power supply, we are supposed to give that power supply to the stator. At that time, what will happen? Here we are using the inductor because here we are using the winding. So winding matlab kya hai? Inductor R hai. So there is a concept of magnetic field. And as we are taking here in the construction of AC motor, we are using the rotor. So we can say its rotating magnetic field will set when we will give the three-phase power supply. And the stationary rotor cut the revolving field. And due to electromagnetic inductions, or you can say according to the Faraday's first law, EMF will get introduced in the rotor conductor. And as rotor conductor, its short circuited current will flow through them. So here, when we are giving the power supply at that time, if that rotor will cut the field, EMF will get introduced. So here, it will becomes a current carrying conductor in the magnetic field and rotor will start to rotate. So when we are giving the power supply and EMF will get introduced and rotor will rotate. At that time, it will convert that electrical energy into mechanical energy. So here, that induction motor rotor always rotate at a speed less than synchronous speed. This is the very important. This question, you will get the question on the numericals, on the MCQs also. You will get question, induction motor rotor always rotate at a speed that will be greater than, equal to, less than synchronous speed. So remember always इंडक्शन मोटर का रोटर का जो स्पीड होता है कैपिटल एन, इट विल ऑलवेज बी लेस एज कंपेयर टू द ns, means n will be less than synchronous speed. So we can say the difference between synchronous speed and the rotor speed is called as a slip. यहाँ पे flux लिखा है by mistake, but you will need it here synchronous speed. So the difference between synchronous speed and the rotor speed, we are calling that as a slip. And if you are supposed to derive the percentage of slip, at that time you can derive ns minus n upon ns into 100. So you will get here the percentage slip. And if we are calling that as a slip, how will you get? Ns minus L. So here if you see, practically three-phase induction motor will look like this. This is the image for three-phase induction motor. If you see its internal parts, you can see their terminals of the three-phase induction motor. Here we are supposed to give three-phase power supply. हमें यहाँ पे three-phase power supply देना है. If you see its cut view of the three-phase induction motor, here this cylindrical like structure. Taza, you are supposed to join class on time. Okay. This will be the stator. This will be the stator. So here if you see, here we can say that as a non-drive end, because here we are not giving the supply. We are supposed to give supply to this side. You can see here. Here we are connecting three phase. 1, 2 and 3 phase. So here, अब किसी का क्वेश्चन रहेगा मैम उसके पीछे भी तो 3 दिख रहा है. When we have seen how to give the power supply, we are using the RYB phase sequence. So if we are using the 3 wires, other sides further they have given R dash, Y dash, B dash like that. Here we are using the fan for cooling purpose. You can write here if you want, other you can skip. Here we are using the fan to get airflow, so it will become cool. This is the stator, and on the shaft we are using that as a rotor which will rotate. Now, so here we can see about the construction of three-phase induction motor. When we are supposed to make the three-phase induction motor, at that time you will be needed main 2 parts. These are nothing but stator and the rotor. Stator and the rotor. So here frame is nothing but which will give the mechanical support to the whole assembly, which will give outer frame. We can say that as a frame which will give the protection. Stator, in that stator winding, stator core, stator frame. After that you are supposed to use rotor. In that there will be the rotor winding. After that we are supposed to use their cooling fan, brushes and bearings. So here, when if there is a question on theory like explain the construction of three-phase induction motor, at that time the compulsory needed the components, these are nothing but rotor and the stator. After that there will be, you are supposed to use frame, that is the outer covering, and brush. These are the important, you are supposed to write. After that you can explain. Frame is nothing but which will give the outer covering to the three-phase induction motor, and it will give the mechanical support to the stator and the rotor of the three-phase induction motor. Stator, you can say it will be the stationary part, and it will be consist of stator winding, stator core, and here when we are supposed to see the arrangement of the three-phase induction motor, you can see here this will be the rotor, this will be the rotor, and here ये जो है पाइप जैसा जो दिख रहा है, we can say that as a shaft, and here we are supposed to give three-phase supply. So here we can say that as a drive end, that will be the non-drive end, and this will be the stator. Then you can explain about the rotor, like rotor is the rotating part of the three-phase induction motor which will be placed in the stator, because outer side is a stator. After that we are supposed to put here rotor, so we can say outer frame, or you can say yoke, stator frame. After that you are supposed to use stator, in that stator core, stator winding. After that rotor, so rotor will be placed in the stator, and rotor is made up of several thin steel laminations, and here when we are using the copper to make the slots, at that time you are supposed to supposed to put there some space. So in the stator and the rotor, there will be introduction of the airflow. So you will get that airflow you can use for cooling purpose. After that, on the rotor, there are two types of the two types of induction motor. These are nothing but squirrel cage induction motor and the slip ring induction motor. So if there is a slip ring induction motor, you are supposed to use slip ring rotor and additional brushes to make the three-phase induction motor as a slip ring. And if we are using the squirrel gauge motor at that time, there will be no needed these bearings and the slip rings. So here we can say about the rotor, it is the rotating part, it is housed on the shaft of induction motor, or we can say it will be housed on the shaft of induction motor and it will be inside the stator. It has two ends, driving and the non-driving. On driving end, we are supposed to give the power supply, and non-driving, you will put on the earth. It means what? You will be put on anything, means where you will be needed. You can locate that. After that, mechanical load is connected to the driving end. And why we are connecting cooling fan to the non-driving? Both ends are connected with the bearing like DC motor. If you see the DC motor, we are using both sides the brushes. Like that, here we will need the bearing for the free rotation, means it will reduces the friction losses. And arrangement of rotor and stator in the three-phase induction motor you can see here. This will be the stator. This will be the stator winding. This will be the power supply. Outer yoke. This is the rotor. And this is nothing but the shaft. So here you can see the components arrangement of the three-phase induction motor, how we are taking. So these are the bearings you are supposed to take on the both sides. You can see this side, this side. After that, we are giving here casing cap. So you can say that as a yoke or the frame. After that, you are supposed to use their mounting plate. केसिंग कैप के बाद क्या है यहाँ पे देयर इज अ माउंटिंग प्लेट सो इट विल बी वर्किंग एज अ outer covering, so it will be also as a stator frame. After that, there will be the stator winding. In that, you are supposed to put their rotor, and this inside the rotor there is a shaft. So these are the components. These diagrams you are not supposed to draw. Only you will get how the assembly of three-phase induction motor will look like, how we are using practical. Just because of that, they have explained here. If there is a question, explain the construction of three-phase induction motor with diagram. At that time, you are supposed to draw the diagram. You can draw any diagram, only you are supposed to write the names. How we are using the rotor, yoke, bearings and stator winding. These things are the necessary. So here you can see, you can draw this diagram also. Any diagram you can draw if there is a construction of three-phase induction motor. Only you are supposed to give the proper names. This will be needed. Shaft, stator, rotor, bearing. This will be compulsory needed there. So here you can see the diagram. So here now, when we are giving the power supply to the induction motor, how we are giving? We are giving that power supply to the stator. How we are giving to the stator? Just wait for a minute. So here, when we are giving the power supply, at that time, we are giving that power supply as a three-phase and we are giving to the stator. So here, we can give that power supply in two manners. We can give as a star connection or a delta connection. So when we are using the rotor winding, it will be wound as a rotor bound and it will be short circuited at both ends through the end ring. So you can see the cross sectional view of the stator and the rotor. ये भी diagram तुम draw कर सकते हो. So here there are two types of three-phase induction motor according to the rotor constructions. We are classifying three-phase induction motor into two categories. These are nothing but squirrel gauge induction motor and a slip ring induction motor. So here you can see about the slip ring squirrel gauge induction. You can see the diagram for the squirrel gauge induction motor. So here, when we are supposed to use squirrel gauge induction motor, at that time, rotor of three-phase squirrel gauge induction motor is look like a cylindrical in shape. The same as we are saying about the three-phase induction motor. And here, the slots are not parallel to each other, but they are skewed. These slots. So here we can say that skewing prevents the magnetic locking of the stator and the rotor teeth. So thus working of three-phase induction motor is improved and it will get less noisy. As we are using here to make the stator winding, we can use here copper bars. And if you see about the squirrel gauge rotor, okay. So here you can see here these bars when we are using are called, we can call as a rotor conductors, and they are placed in the slots on the periphery of the rotor, and these rotor conductors are permanently shorted by using the copper bars. So here they will provide the mechanical strength and they will form the complete closed circuit. So we can say that will look like a cage, जैसे पिंजरा ऐसे. It will look like this. Just because of that reason we are saying that three-phase induction motor as a squirrel gauge induction motor. After that, if you see it's if you see its cut view, it will be look like this. Here we are using the core. These are the slip rings. So now if we are talking about the slip ring induction motor, at that time there will be addition of the slip ring in the squirrel gauge induction motor. So we can say the slip ring induction motor or the wound rotor motor, we are giving the name to the squirrel gauge induction motor when we are supposed to use their slip ring. At that time, if we are using the slip ring, you can see here, these are the slip rings. एक के बाद ये जो दिख रहा है, these are the slip ring. If we are using, at that time only we are supposed to say these as a slip rings. Actually here there will be the name required as a slip ring. So here, if we are using the slip ring, it means what? We can say the rotor of wound induction rotor motor will consist of slots and rotor winding. So these are placed inside these slots. And the three end terminal of three-phase induction motor are connected to form the star connections. So we can say three-phase slip ring induction motor consists of slip rings. These are connected on the same shaft where will be the rotor. ये जो shaft है, on that we are using the rotor. There also we are using the slip rings. So we can say the slip rings are connected on the same shaft as that of rotor, and it has a set of windings on the rotor which are not short circuited. So here if we are using the slip ring on the same shaft of rotor, at that time you will get higher slip, and yeah, as you will get the higher slip, you can say you will get their higher torque. So if we will talk about the advantage of the slip ring induction motor, you can say it will have higher starting torque, and there will be the requirement of low starting current for the slip ring induction motor. So we can say these are the advantages for the slip ring induction motor. But if you see its construction, its assembly construction is becoming complex because there is a there is a need of slip rings, additional slip rings, and the brush assembly. So it will require regular maintenance. So we can say that as a disadvantage for the slip ring. And if we will talk about the squirrel cage induction motor, its advantages, its construction is simple. And if we see its disadvantage for the squirrel cage, here you will get the low starting torque. Now, you can see the arrangement of the slip rings. These are the slip rings. How we are connecting one by one. After one, we are connecting. This is the cut view of the slip ring induction motor. This is the shaft. This is the fan. Here, when we are using the slip ring induction motor, you can see here. These are the slips. So now we are supposed to see the industrial applications of the slip ring induction motor and the comparison of the squirrel gauge and the slip ring induction motor. And we will see their applications also. If you see the construction of squirrel gauge induction, at that time we will say there is no need of additional brushes, there is no need of additional slip ring. So we can say most of application of industrial as well as domestic are will uses the squirrel cage induction motor because its construction is simple. It is simple. It is cheap as compared to the slip ring because एडिशनल पार्ट जो स्लिप रिंग्स ब्रशेस है वो यहाँ पे नहीं लगता है तो उसका कॉस्ट कम हो जाएगा एंड एज वी विल नॉट रिक्वायर दिस कंपोनेंट्स इट्स मेंटेनेंस विल बी आल्सो इजी and we can use squirrel cage induction motor at explosive area and its starting torque is low as compared to the slip. If we will talk about the applications for the squirrel cage, we can take the applications like compressor, centrifugal pump. We can use squirrel cage in the agriculture where cost is the important factor and where you will need the low cost. Now we can see about the slip ring. As we are saying, advantage of the slip ring because it is giving higher starting torque. So where we will need the higher starting torque at that places we can use the slip ring induction motor because it is having the torque value which will be high as compared to the squirrel cage induction motor. But its construction is complicated because there is a additional slip rings and the brushes will be needed and its maintenance cost is high because here when we are using the slip rings and the brushes they will need the regular maintenance. We can say here we will require starter and we are seeing three-phase induction motor will not need of a starter. So if you see about the slip ring it will need the starter compulsory. We cannot use a slip ring induction motor at an explosive area. And if we will talk about its application, you can take the applications as crane, hoist, lift, where we will require higher starting torque. So we can use their slip ring induction motor. क्लास फिनिश हो गया है अभी अजय ने ज्वाइन किया है okay so here we have finished about the constructions and the types of squirrel cage induction motor. We will see some numericals and the equations of the squirrel cage and slip ring induction motor in the next session. If anyone is facing any issue, you can ask me. So in today's session, we have seen about the three-phase induction motor where we are giving the three-phase supply. And we are saying that as a electromechanical energy converter because it is using the electrical energy and it is converting that electrical energy into a mechanical energy. Then we have seen if we are supposed to see the construction of three-phase induction motor, mainly it will require two parts. These are stator and the rotor. In stator, there will be the stator frame which will give the outer covering, which will give the mechanical support to the rotor and the stator of the three-phase induction motor. Then we have seen we are using the stator winding. We are using their we are using their rotor. So rotor is nothing but it is the rotating part of the three-phase induction motor. When we are giving the power supply to the stator of three-phase induction motor, at that time rotor will rotate, and due to which if rotating magnetic field will cut by conductor at that time, according to the electromagnetic induction, EMF will get introduced. So then we have seen there are two types of three-phase induction motor depending on the construction of rotor. So if we are using the slip rings and additional bearings on the same shaft where we are using the rotor, at that time we can say that type of three-phase induction motor as a slip ring induction motor. But if we are using the additional part, its cost will become high and there will be need of maintenance. And if we will talk about the squirrel cage induction motor, then it is the squirrel cage induction motor will be a look like a cage, because here we are using the copper bars which will give the mechanical strength, and here there is no need of additional slip rings. So we can say its construction is simple as compared to the slip ring induction motor, but it will give us low starting torque. If we will see about the applications of the slip ring induction motor, we can use the slip ring induction motor in the lift, we can use in the lift, hoist and crane where we will require the higher starting torque. And if you see the applications of squirrel gauge, we can use the squirrel gauge induction motor in the agriculture where we will require low starting uh, torque and we will require cost will be minimum. So we can use the squirrel cage induction motor in the lithium machine, compressors, centrifugal pump, where you will be supposed to pay low cost as compared to the cost for the slip ring induction motor. Remaining we will see in the next class. Okay, so you guys can leave now. Thank you. If anyone is facing any issue, then you can ask. I will share the notes on the classroom for our fourth unit. Okay. Thank you.